Let's take a look at these physics practice problems together. I've created these questions across different topics in physics curriculum, from mechanics. Number 2 is from wave and optics. Number 3 is from current electricity. Number 4 is from fields and electrostatics. And number 5 is from atomic and modern physics. Actually, you can easily screenshot each of the questions if you want to try them on your own before I go ahead to solve all of them. So let's start with question number 1. We have a body of mass 2 kilograms, which is projected from ground level with a velocity of 50 meters per second at an angle of 30 degrees to the horizontal. Calculate the kinetic energy of the body at maximum height of its trajectory. We're using G equals 10 meters per second squared. So a projectile, when you look at a typical projectile, it follows a path of this nature. And so what we observe about the velocity of this guy is that there are two components to its velocity. There will always be the horizontal component of velocity and there will be the vertical component of the velocity. When the body is moving up, the horizontal component of the velocity is actually always constant throughout the entire journey. The horizontal component is always constant, but the vertical component of the velocity, as it is going up, it is actually decreasing. So from the initial horizontal and vertical velocity to the as you begin to go up to the second one, to the third one, to the fourth one, the velocity is decreasing as it is going up, which shows a form of deceleration. So when you get to a point, this point is known as the point of maximum height. Don't forget, the horizontal component of the velocity still remains the same, but the vertical component of the velocity will become zero when it reaches maximum height. By the way, when it is coming down again, the vertical component of the velocity will now be increasing. The horizontal still remains constant. So which implies that at this point now, to get kinetic energy is simply half mv squared. And v here is the magnitude of the velocity. Magnitude of velocity is the square root of v horizontal squared plus v vertical squared. But we are lucky in this case because at maximum height, v vertical is 0. So therefore, the v we need is just the vh. So for vh in this place, since the angle 30 degree is made with the horizontal, that implies that the horizontal component of the velocity is going to be 50, which is the magnitude here, cosine 30 degree. That will be 50 cosine 30 degree. That will be 50 times 0.8660. So let me quickly press that. Cos 30. So that's or I could just use the 50 root 3 over 2. So that would be 25 root 3. That's the velocity. That's the velocity, horizontal component of the velocity. And since like I said, the magnitude of the velocity will be the same as the magnitude of the horizontal component of velocity when we are at maximum height. So therefore, the kinetic energy I'm looking for, kinetic energy will then be 1 over 2 multiplied by the mass is 2, then multiplied by the square of v, which is 25 root 3 raised to power 2. So these two cancels out, and we have 25 squared multiplied by 3. So that's 1,875 joules. So that leaves us with the correct answer of 1,875 joules of kinetic energy. That's for question number 1. Let's go to question number 2.